So now, how can we find force A and angle X? In resolution of forces, when we have the resultant of two or more forces, the X component of the resultant must always be equal to the summation of the X component of all the forces that make up the resultant. The same goes for the Y component. The Y component of the resultant of two or more forces is always equal to the summation of the Y component of each of the forces. So now we can say f of x of the resultant equal to f of x of A plus f of x of B, and f of y of R equal to f of y of A plus f of y of B. We already noted that the x component of a force is f cos theta if theta is the angle the force makes with the x-axis, or f sine q, where q is the angle the force makes with the y-axis. So coming back to the resultant, 30 degrees is the angle the resultant makes with the x-axis. So the x component of the resultant is 160 cos 30 degrees. So we can substitute here. Coming here to force A, angle S is the angle force A makes with the y-axis, and hence the x component of force A is A sine S. Substitute it here. Now here, force B, this angle here, 23 degrees, is the angle force B makes with the y-axis, and hence the x component of force B is 100 sine 23 degrees. So if we substitute here now, 160 cos 30 degrees equal to A sine S plus 100 sine 23 degrees. Making A sine S the subject, we subtract 100 sine 23 degrees from both sides. Now A sine S equal to 160 cos 30 minus 100 sine 23. 160 cos 30 minus 100 sine 23 is 99.491. So A sine S now equal to 99.491. We have two unknown variables from the equation, and hence we can solve it using this equation alone. Now coming back to the y component of the force, the y component of a force is f sine u, where u is the angle the force makes with the x-axis, or f cos v, where v is the angle the force makes with the y-axis. 30 degrees is the angle the resultant makes with the x-axis, and hence the y component of the resultant is 160 sine 30. Substitute here. Angle S is the angle force A mixed with the y-axis, and hence the y component of force A is A cos S. Substitute it here. Coming to force B, 23 degrees is the angle the force makes with the y-axis. But if you look here, force B is in the negative y-axis, and hence the y component of force B is minus 100 cos 23. So now, sine 30 degrees equal to A cos S plus open bracket minus 100 cos 23 degrees, which is the same as A cos S minus 100 cos 23 degrees. Making A cos S the subject, A cos S equal to 160 sine 30 degrees minus open bracket minus 100 cos 23 degrees. Here minus times minus is plus. So A cos x equal to 160 sine 30 degrees plus 100 cos 23 degrees, which is 172.0505. So A cos S now equal to 172.0505. And here we have A sine S equal to 99.491. In trigonometry, there is an identity that tan theta equal to sine theta over cos theta. So we can solve simultaneously by dividing this equation by this equation. Now A sine S over A cos S equal to 99.491 over 172.0505. Here A cancels A, and here 99.491 over 172.0505 equal to 0.5783. So sine S over cos S equal to 0.5783. From this identity here now, we can substitute that sin s over cos s equal to tan s. So now tan s equal to 0.5783. To find s now, we find the tan inverse of 0.5783. Now s equal to tan inverse of 0.5783, which equal to 30.04, approximately equal to 30 degrees. So this angle S now is 30 degrees. To find force A now, we can substitute S equal to 30 degrees into any of these two equations. So let's substitute it here. Now A sin 30 degrees equal to 99.491. To find A, we divide both sides by sin 30. So A sin 30 degrees over sin 30 degrees equal to 99.491 over sin 30 degrees, which equal to 198.982, approximately equal to 99. So force A now equal to 199 Newton, and we found angle S to be equal to 30 degrees.